Hi, in this video I'm going to solve power cycles quotients and specifically it's all about power cycles unit digit quotients. I'm going to solve all the levels of difficulty quotients. In the previous video I've explained you the concept of power cycles and how to find the unit digit of any number raised to any power. And also at the end of the video I've given you 10 quotients. If you haven't solved it, you can solve and then you can watch this video. You can get all those 10 questions in the previous video as well as a particular worksheet. You can find the worksheet in Facebook page of KISH classes. Let's solve question number 1. So I've given 4 questions and there is no answer option for all these 4 questions. So find the unit digit of 1 power 2 factorial into 2 power 3 factorial into 3 power and so on up to 5 power 6 factorial. This must be very easy. We just need to find the unit digit of every number and we need to multiply it. Now 1 power 2 factorial is nothing but 1 square. That 1 square unit digit is 1 into 2 power 3 factorial is nothing but 2 power 6. First let me write this number is 1 square into 2 power 6 into 3 power 24 into 4 power 120 into 5 power 720. Now 1 square unit digit is obviously 1. 2 power 6 unit digit is 2 raised to any power will get 4 different unit terms. So the cycle size is 4. So 1 cycle and then second cycle second term. Second cycle second term means it's like 2 square term. 2 square is 4 here. 3 raised to some number, we found that the number of different unit digits that we get is 4. So now 24. So it means that we are going to get exactly 6 complete cycles. So the end of the 6th cycle, it means that the last term of the cycle. So that is 3 power 4 cycle. 3 power 4 will get 1 here. 4 power 120. In 4 cycle we will get 2 different terms. That is 4 power 1 is 4. 4 square is 16. So 4 and 6 are the 2 unit digits that we get. Here we will get 60 cycles. So 60th cycle last one is nothing but the first cycle last one. So first cycle last one is 4 square unit digit, that is 6 here. 5 raised to any number, we are going to get 5. So that's 1 into 4 into 1 into 6 into 5. That's going to be 120. So we need to focus on unit digit, that is going to be 0. Now this is one simple way. This is what we have applied our concept. So this based on application of concept. Second one, we can apply strategy, or we can easily say that we can apply common sense. Now if you observe this one, 5 square, we are going to get the unit digit is 5. These are two numbers which are even numbers. Even number raised to any power, we are going to get its unit digit as even number. So 5 into even number, it ends with 0. 0, it's unit digit. That's it. So you don't have to really find 2 power 6 unit digit or 3 power 4 for every term unit digit. You just primarily focus on 5 power unit digit and then some even number. Let's move to question number 2. Find the unit digit of 1 power 2 factorial plus 2 power 3 factorial and so on up to 5 power 6 factorial. This is the same question except that we have changed sign. For the earlier question it was multiplication, now this is addition. So it means that we cannot apply any strategy. We cannot directly say that okay, 5 factorial is ending with 5, so even number ends with 2, even number ends with an even number raised to any power ends with an even number, so 5 into even number. No, here we are adding. So in such a case we have already found that the unit digits are 14165. That's going to be 17, so unit digit is 7 here. Let's find question number 3. You can apply strategy or you can apply concept. So this number is 1 factorial whole power 2, so that is 1 square. 2 factorial whole power 3, that is 2 cube. 3 factorial whole power 4, that is going to be 6 power 4. 4 factorial whole power 5, that is going to be 24 power 5. 5 factorial whole power 6 is 120 whole power 6. Now we don't really need every digit here. If it's a 2-digit number, we don't need all the digits. We just need the last two digits. So here also we don't need these two. We just need 0 power 6. Now instead of trying to find one square unit digit is 1, or 2 cube unit digit is 8, 6 power 4 unit digit is 6, 4 power 5 unit digit is 4, and 0 power 6 unit digit is 0, you can directly say the answer is 0. You can directly say that since 0 power 6 is 0 and 0 is multiplied with any number, it's going to be 0. It's a very simple thing. Let's solve question number 4. Find the unit digit of the same number. However, in the place of multiplication, we have given addition. It means that we just need to add all of them. 1 plus 8 plus 6 plus 4 plus 0. That's 19. So unit digit is 9 here. You just need to apply common sense. If at all, if you feel that you cannot have a strategy or a common sense, the best alternate thing is to apply the concept. Application of the concept will give you 100% of the marks. It probably may take 10-20 extra seconds. But once you focused on application of the concept, then you can easily eliminate almost like 99.9% of the students. So once you reach that bracket, that is like 99.9 percentile, the remaining you just need to have some smart strategies to outlast the competitors. So to reach 99.9, you just need application of concepts. Thorough with all the application of concepts, that's enough. That's our question number 5. Again, I have given 2 questions without answer options. Now find the unit digit of 123 whole power 4567 factorial into 765 whole power 4321 factorial. Now it's a very big number. However, we don't need this part. We just need to focus on unit digit. So this number is down to 3 power 4567 factorial into 5 power 4321 factorial. Now you can apply a strategy, but if you really want to find the unit digits, that we can always do. Now 3 power 4567 factorial, and we need to find its unit digit. 4567 is not the number, it's a 4567 factorial is the number. As usually, what we need to do is like we need to divide 4567 factorial by a number 4. The number 4 is the cycle size of 3. The cycle is nothing but the different unit digits that we get when 3 is raised to any power. Now 4567 factorial divided by 4 is very simple. 4567 factorial is nothing but 1 into 2 into 3 into 4 and so on into 4567. If we divide this number by 4, what happens? The remainder, we are focusing on remainder, we are not focusing on value. So 4 is there, 4 is there. So remainder is going to be 0. When the remainder is 0, we need to take the last term of the cycle. In the 3 cycle, the last term is, which is 3 power 4 unit digit, that is 3 power 4 is 81, that is 1. So it's quite simple. So 3 power 4, 3 power 4, 5, 6, 7 factorial unit digit is 1. 5 raised to any number, that's very simple. That's always 5. That's 5. That's going to be 5. Now you don't really need to find 3 power 4, 5, 6, 7 factorial. That is not required here. Without finding 3 power 4, 5, 6, 7 factorial, you can solve this question. That is like you just need to apply the common sense or strategy. So 5 power some number always ends with 5. Now 3 is, it's an odd number. Odd number raised to any number, it ends with odd number. Now odd is 1 into 5 is 5. So 1 into 5 is 5. 3 into 5 it's 15 is ends with 5. 5 into 5 25 it ends with 5. 7 into 5 is 35 it ends with 5. 9 into 5 is 45 it ends with 5. So you can directly focus on just odd it. Odd into 5. Even into 5 ends with 0. Odd into 5 ends with 5. That's a very easy one. Let's solve question number 6. Find the unit digit of 15 power 51 into 51 power 15. This must be very easy. So we don't need the first term, we just need the unit term. This number is down to 5 power 51 into 1 power 15. 5 power any number ends with 5. 1 power any number ends with 1. So that's going to be 1 into 5 is 5. This is a very easy question. Now CAT questions are this much easy. Let's solve question number 7. Find the unit digit of 7 power 3 power 4n plus 1. So that is, this number is 7 power 3 whole power 4n and here plus 1. And n is a natural number. Look at this one, it's a natural number. A variable is given here, it's a variable, and answer options are given in numbers. So variable to numbers based question, it means you have the flexibility of taking any variable in the place of n. For every single variable, you must be able to get the same answer. Now in such a case, since you have the flexibility, it is better if you choose the minimum number. Since n is a natural number, n can take a minimum value 1. So it means that this down to 7 power 3 power 4 into 1 plus 1, that is nothing but 7 power 3 power 8 plus 1. 3 power 4. Now 3 power 4 is nothing but 81. So 7 power 81 plus 1. 7 power 81 unit digit. That's what we need to find. 7 power 81 unit digit is very simple. 7, the cycle size is 4. We will get 4 different unit digits, that is 7, 9, 3, 1. Now here 81, that's nothing but 7 power 81 by 4 remainder. So that is 1. So this number is down to 7 power 1 plus 1. 7 power 1 means it's the first cycle. It's not 7 power 1, it's the first term of the cycle. So first term of the 7 cycle is 7. 7 plus 1 is 8. That's very easy. Now, if at all, if you feel that in place of n, if you take some other number, we probably may get a different answer. So let's check. Why should we really worry about here? So this is nothing but, so if n equal to 2, then it's 4 into 2, that's going to be 7 power 3 power 8. That is going to be 7 power 3 power 8 is nothing but 6561 plus 1. Now 7 raised to any power, we will get it have 4 different unit digits. So it means it is 7 power 6561 by 4. A reminder, if a number is divided by 4, we just need to divide the last 2 digits of the number by 4, because it's nothing but it's of the format 2 power x, that is like 2 power 2. So if a number is divided by a number which is of the format 2 power x, we just need to divide the last x digits of the number by 2 power x, that's it. Here 4 is 2 power 2, so we just need to divide the last 2 digits, that is 61 by 4. Here we get the remainder 1. If the remainder 1, it's again the first term of the cycle, which is 7. 7 plus 1, that is 8. Now irrespective of n, we will get the same value. You don't really need to check for 2 or 3 different values. Once you come across that the answers are, the question is given in variable, answer options are given in numbers, it's very straightforward, simple. For any value of n, we will get the same answer. Now, but you just need to be a bit careful here. If one answer option D says that cannot be determined, cannot be determined, none of the above, or both answer option A and C, you just need to be careful there. However, CAT is very simple. They haven't given this much difficult. They have given very low level questions in power cycles. You just need to know the concept. If you have no idea about the concept, then it's very difficult for you to solve the question. Then you can probably rate the question as very difficult. But however, once you know the concept, then you feel that it's just like that. You just need to solve this question in 30 seconds, 40 seconds. This is where you can save a good amount of time. Let's solve question number 8. The unit digit of 11 power 11 factorial plus 12 power 12 factorial and so on up to 80 power 80 factorial. And also one answer option says that it is none of these. Very good. You should know how to approach, and you should know how to apply the concept, or you should know how to apply strategy or common sense. Let's see how to approach this number. It's quite simple. 11 power 11 factorial is nothing but 1 power 11 factorial. Any number a, b, c, d whole power p, q, r is nothing but we just need to primarily focus on d power p, q, r unit term. So here in such a case, this question is down to 1 power 11 factorial plus 2 power 12 factorial plus 3 power 13 factorial and so on up to 9 power 19 factorial plus 20 is nothing but 0 power 20 factorial plus 1 power 21 factorial and so on. So that is again 0 power 80 factorial. Now, how to solve this one is, now after this step, you just need to apply the concept carefully. 1 power some number is going to be 1. Now, here onwards we are getting bigger numbers. In the power we are getting factorials, that is 12, 13, 14, 15. These are very, very big numbers. What we can apply this one is quite simple. Irrespective of the number of units that we get for 2, 3, 4, 5, 6, what we commonly do is we divide the power with the number of different unit digits of that particular number. Now for 2 we will get 4 different unit digits, so that is nothing but 12 factorial by 4, plus for 3 also we will get 4 different, that is 13 factorial by 4. For 4 we will get 2 different unit terms, that's divided by 2, and so on. So 9 whole power 19 factorial, for 9 we get 2 different unit terms, and so on like this. Now whatever happens, 12 factorial divided by 4 or 13 factorial divided by 4, 14 divided by 4, the reminders we get 0, because 12 factorial has got 1 4, 1 into 2 into 3 into 4, so it has got 1 4 multiple, then obviously the remainder is 0. We are not talking about value, right? So we are talking about reminders, so reminders would be zeros. Whenever the remainder is 0, that is the first term of the cycle. For 2 cycle, first term is 2 power 1, that is 2. For 3 cycle, first term is 3 power 1, that is 3. So like this, it's 1 plus, 2 plus, 3 cycle is 3, 4 cycle is 4, 5 cycle is 5, 6 cycle is 6, 7 cycle is 7, 8 cycle is 8, 9 cycle is 9, and then 10 it's always 0. Again, no, one second. Again, starting from 21, that's nothing but 1 power 21 plus 2 power 21, we are going to get the same numbers here. So this sum into 7 times 11 to 20 is 1, 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80. Like this we are going to get 7. Now we just need to add all of them. Just add all of them, and then it's down to quite easy. Now addition is very easy because the numbers are in arithmetic progression. So first term plus last term by 2. So you can take this as, instead of 0 you can take 10 also. Anyhow, this is just 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 0 into 7. That's it. You just need to apply the concept carefully. Now once you solve very, very difficult questions, or very not difficult questions, questions where a lot of application part of concept is involved, or questions are a bit tricky in nature, or where you have no idea about how to approach the question, if you solve all those questions carefully, then you don't need to solve many examples. One example, if the moment you solve one very difficult question where the application of the concept is the primary thing, then you don't need to solve any other question. Identify those questions, solve them. Let's we move to question number 9. The sum of the third powers of first 100 natural numbers ends with. Should we solve this question? This question is like 1 cube plus 2 cube plus 3 cube and so on up to 98 cube plus 99 cube plus 100 cube. You can apply sigma n cube. That is nothing but n into n plus 1 by 2 whole square. That is, this is sigma n cube. That is nothing but n into n plus 1 by 2 whole square. Since n is 100, 100 into 101 is going to end with double zeros. Double zeros raised to power n with 4 zeros divided by 2, we are going to get 0. But should we really apply algebra concept? No, we are supposed to apply the power cycles concept. Getting the answer is not the target when you started the preparation. In the examination, getting the answer is the primary target, and that is the only target in fact. But when you are learning, actually you just need to apply the concept. Application of the concept is the most important thing. So that's why, let's say we will apply. So 1 cube plus 2 cube plus 3 cube and so on up to 100 cube. This is nothing but, so 1 cube plus 2 cube plus 3 cube and up to 9 cube. For 10 cube, we'll write it as 0 cube. For 11 cube, we'll write it as 1 cube. 12 cube, we'll write it as 2 cube, and so on up to 91 cube, we'll write it as 1 cube. 92 cube, we'll write it as 2 cube. 98 cube, that's we'll write it as 8 cube plus 99 cube is 9 cube. 100 cube is 0 cube. What are we getting here? It's 1 cube up to 0 cube. Again starting from 1 cube up to 0 cube. Again 1 cube to 0 cube. That's like this. How many sets are here? 10 sets. 1 to 10, 11 to 20, 41 to 50, 81 to 90, 91 to 100. So like this, we'll get 10 sets. So whatever the result, this result is same for every set. So that's going to be x into 10. X into 10 ends with 0. We don't need to find 1 cube, 2 cube unit digit or 3 cube unit digits. You just, whatever the sum that is multiplied by 10, since 10 has unit digit 0. So any number multiplied by a number which is ending with 0, the result ends with 0. Let's solve question number 10. With this one, we finish the session. And this is also a question where level of difficulty is very high because of the nature of the question and also length of the question. However, this question is very important because once you solve this question, then you can solve any question. Any type of question that's going to be asked in CAT. Let's see if we have got 13 raised to 1 factorial plus 2 factorial plus 3 and so on to 13 factorial plus 28. And that's raised from 1 factorial to 28 factorial sum. Next 32. That's also same 1 to 32 factorial sum. Next one is 67. Then what is the unit digit of n? Now what is this one? 13, 28, 32, 67. There is no relationship. These are not conjunctive numbers. And they are not special numbers also. They are not even prime numbers. They are not very, very special numbers. Now, since these are some random numbers, what happens if in the next time, what happens next time we are going to get, instead of 13, we are going to get 23, instead of 28, we are going to get some 37, instead of 32, we are going to get, let's say 81. So we probably make a different ones. Now, do remember, it's like some number raised to a power which is sigma n factorial. That is 1 factorial plus 2 factorial. What you need to understand is quite simple. So 13 power some number is 1 is not needed. So it is down to 1, 3 power 1 plus 2 factorial, 3 factorial and so on up to 13 factorial here. Same is the case. We don't need 2 here. We just need this one. We don't need 3. We just need this one. We don't need this one. We just need this one. Now, what we need to know is like whenever 3 is raised to some power, we are going to get 4 different unit digits. To find the exact unit digit, we need to divide the power with 4. That is nothing but the number of unit digits that we get. Now, that is nothing but 3 power 1 factorial plus 2 factorial plus 3 factorial and so on up to 13 factorial. That is by 4. You need not identify how much is 13 factorial, 12 factorial and all. No matter what happens, this we can do as 1 factorial by 4 remainder plus 2 factorial by 4 remainder plus 3 factorial by 4 remainder plus 4 factorial by 4 remainder plus 5 factorial by 4 remainder and so on up to 13 factorial by 4 remainder. Now, if you pay close attention, from 4 factorial onwards, for every term, the numerator contains 4. And we are dividing the number with 4. It means that the remainder must be 0 for all these numbers. 4 factorial by 4. 5 factorial has got 4. So 1 into 2 into 3 into 4 into 5 by 4. So it becomes 0. For all these numbers, the remainder is 0. So it means we are down to 1 factorial plus 2 factorial plus 3 factorial by 4. That is nothing but 9 by 4. So its remainder is 1. It means that the first term of the cycle. Let's check for some other 28 also, for other numbers. 8 also, the number of unit digits, are going to be, the cycle size is going to be 4. So it means that again we need to divide with 4. The next number is 32. So that's 2 power some number. So we need to divide with 2. We need to divide with 4. The cycle size of 2 is also 4. Now next one is 67. 7 power some number. We need to divide the power with the cycle size of 7, that is also 4. For all these numbers, that is 3, 8, 2, 7, the common thing is the number of units we are going to get is 4. So power raised to 4. For all these numbers, powers up to 1 factorial plus 2 factorial plus 3 factorial are important. Remaining, we will get the remainder 0. In such a case, so 3 power 9, this question is down to 3 power 9 plus 8 power 9 plus 2 power 9 plus 7 power 9 unit terms. 3 power 9 is nothing but 3 power 9 by 4, that is remainder 1. So that is first cycle, first term of the cycle, that is 8 power, 2 power, 7 power. That is going to be 3 plus 8 plus 2 plus 7. So we'll get the unit term 0. Okay, the question itself seems to be a bit complex, a bit scary, and probably we think that we are going to waste a lot of time by solving this question. No, in fact, you don't waste any time. The moment if you can solve a question within 2 to 3 minutes, and where almost 95% of or 99% of the students ignore the question, that is your big advantage. You eliminate all the gang which primarily focus on leaving some question where the application of concept is involved. I accept that we need to leave tricky questions, we need to leave questions which take longer time, and also we need to avoid a lot of questions where we are unable to get the clue here. But however, the moment you understand how to apply the concept for any question, just solve it. Even that is taking 2 to 3 minutes. Sometimes it may be taking 5 minutes. That is a very, very significant return. Very significant, very high return. You eliminate all the people behind. Anyhow, in the next video, I'm going to teach you the concept. The concept is how to find the last 2 digits of a cycle, and also the last non-zero number from unit digit, and also followed by a drill. That's about, I'm going to give you 10 more questions. So once we finish that how to find the last 2 digits and then drill exercise, then I'm going to solve all the 6 CAT original questions of power cycles. Thank you.